Hello friends, let's take an Anna University April-May 2011 question. Use source transformation technique to find I naught in the circuit. Here is your I naught and you have 1, 2, 3, 4 resistors and 2 batteries and 1 current source also. Here you can see that we have to use source transformation technique. In many of my videos, I have explained about the source transformation technique. That is, we are converting a combination of a resistor and a voltage source to a current source and a resistor. Also vice versa. Okay. So, here we need a series combination of voltage source and resistor or a parallel combination of the current source and resistor. Then only we can think about the source transformation. Okay. So here let's see which set is available. That is, here you can identify a series combination of a voltage source and a resistor. Isn't it? Even though we have a current source, but we cannot see any parallel resistor. Here you might just get mistaken with the 6 ampere and 3 ohms. But remember, you have a 2 ohms in between. So 6 and 3 is not in parallel combo. Okay. So here we can have a series combination of voltage source and a resistor. In the right side also we have a 24 volt and 6 ohm. So let's take this series combination of voltage source and resistor, or just let's convert this to the parallel combination of current source and resistor. How it is done? We can have a current source and a resistor kept in parallel. Resistor will have the value R itself, and the current source, since the positive is upside, we should have the arrowhead upright and the value is V by R. Okay, so here for 12 and 4 we can have, I'll just draw 12 by 4, that is, and positive upside. 12 by 4 is 3 ampere and the same resistor, that is 4 ohms, should be now connected in parallel to 3 ampere. Fine. So this part is done, converted to this type. And next you have to copy down this 6 ampere and this 2 ohm and 3 ohm is not going to change. And again this 24 and 6. So the 6 will be now connected in parallel to the current source. And here since the positive polarity is downside, you should have the arrowhead pointing downside, and the value is 24 volt divided by 6, that is 4 ampere, and the 6 ohms will come here, and similarly this 4 ohm is going to be over here, 2 ohms is there and 3. Ready? And just note down that this I naught is the current that goes through 2 ohms. Okay. So this is I naught. Okay. So this is the circuit now. And actually you can see that there are 2 junctions mainly coming here. That is, one junction is to the left of 2 ohms and the another is to the right of 2 ohms. That is, to this first point, you can see 3 ampere is incoming and 6 ampere is outgoing. So you can say that the net 3 ampere will be outgoing from this particular point. Let's name it as A and B. Okay, fine. So 3 is incoming to A and 6 is getting away from it. So net, we can say at this point A, a current of 3 ampere will be going on. Just take the magnitude 6 minus 3 and put the magnitude of the bigger one, that is 6 is the highest. So the 3 ampere, net 3 ampere will be going down, and you can have the 4 ohm and the same 2 ohms. Okay, and for this point B, we can see that 3 and 6 are connected parallelly. That is, if this is grounded, we can see that 3 ohm is having 2 ends. One is B and another is ground. And 6 ohm is also having 2 ends. One is to B and next is grounded. So we can say that 6 parallel 3 is the net resistance here. So 6 parallel 3 is 6 into 3 by 6 plus 3, that is 2 ohms. Actually, there is another trick, that is if R and R by 2 is connected parallel, then the net resistance will be R by 3. Okay, so 6 and 6 by 2. So 6 by 3, that is 2 ohms is the net. Okay, so we can draw a 2 ohms here, which will be again back to ground, and this 4 ampere is going down. So this is your final simplified circuit. Now our main task is to get the value of the current that is going through 2 ohms. Okay. So try to maintain the same direction which is given in the question. Okay. Now how to proceed this? Actually we can have many methods, like you can have the mesh analysis, and you can have nodal analysis, or you can have superposition theorem, because you are having two current sources, isn't it? So any of these methods is possible, but here I will go for mesh analysis. Why? Because even though there are more than two meshes, I prefer to mesh analysis because we are having two current source available. That is the current, if I draw the meshes here, I1, I2, I3. Even though I am having three meshes, the value of two currents are already available. Like I1 is the current that is passing through this way, right? So I1 is actually 3 ampere itself, but since the direction is reversed, we have to have negative 3 amps. And similarly here, I3 is the current that passed through the final end. So it is 4 amps itself. Fine. So even though we are having more than two meshes, since the two currents are readily available, we can have this mesh analysis. Now next is to get the value of I2. Actually I2 is the actual answer we just need to have, because I2 is the current through 2 ohm, and in the middle mesh you can see I2 goes through this way, and this way. So I2 is actually equal to I0 itself, which is our question to find out. So I2 equal to I0. Now let's form the equation for mesh number 2. Okay, so starting with this 4 ohm, 4 into current through 4 ohm regarding to this center mesh is I2 minus I1 plus 2 I2 and plus, what is the value here? It is 3, no, it is 2 ohms. So this is 2 ohms. Okay. When 3 and 6 comes in parallel, 2, it is 2, yes. So 2 into 2 is going down. So I2 minus I3 equal to 0. 3 components, so 3 terms, right. Now let's substitute the values for I1 and I3. So here is the answer. I2 is equal to I2, that is I0, the current that passed through 2 ohms is equal to negative 0.5 ampere. This negative actually indicates that the actual current which passes through 2 ohms is towards left. This is the correct direction of the current which is flowing through 2 ohms. So if you like the video, please do like, share and subscribe the channel. Until we meet in the next class, this is Minu signing off. Thank you and take care.